Hey guys, welcome back to my channel. Yesterday we did till question number 5. We did the sub question 1 and it was the same process with sub question number 2, so I didn't do it. Today we'll be continuing and we'll be finishing these 3 sub questions of question number 5, and I'll also do the first and second one of question number 6, exercise 13A, OP Malhotra's textbook for ISC Mathematics. So let's begin. Okay guys, so the third sub-question of question number 5 is integral of cos square x minus sine square x upon root of 1 plus cos 4x dx. So we know that this is cos 2x because the way to find out cos 2x is cos square x minus sine square x. This can also be written as 1 minus sine square x, or if not this, we can use cos square x is equal to, minus sine square x can be written as 1 minus cos square x, which is cos square x minus 1 plus cos square x. So 1 plus cos 2x is equal to 2 cos square x. So we're going to use this later, but first I'm going to write this entire thing as cos 2x. Now that we know that 1 plus cos 2x is 2 cos square x, it means that 1 plus cos 4x is 2 cos square 2x. So that's what we're going to write, 2 cos square 2x dx. The root of this would be cos 2x upon root 2 into cos 2x dx. This gets cut and then we're left with 1 by root 2, and to integrate that we need to replace the 1 with x. So the final answer is x by root 2 plus c. Okay, so the fourth sub question of question number 5 is integral of cos raised to 4x sine raised to 4x dx. Again, we can write this as cos x sine x, the whole thing raised to 4. Cos x sine x, like explained earlier, can be written as sine 2x by 2, the whole thing raised to 4. So when it's raised to 4, it becomes sine raised to 4 2x by 16. We can take 1 by 16 outside, and we can write sine raised to 4 as sine square 2x, the whole square. And like we did earlier, we can replace this sine square with 1 minus cos, we'll use the double angle, 4x by 2, the whole square. This becomes 1 minus cos 4x, the whole square, by 4. We can take 1 by 4 outside, so 1 by 16 into 4, which is 64. And this becomes 1 minus cos 4x, the whole square, which is, so a minus b the whole square is a squared plus b squared minus 2ab, so minus 2 cos 4x. So we can write this as 3 separate terms. Integral of 1 dx plus, and we can write cos square as 1 plus cos, again double angles, so cos 8x by 2 dx minus 2 integral of cos 4x dx. We know that 1 by 64 will remain outside. Integral of 1 dx is x plus 1 by 2 goes outside and 1 becomes x, cos becomes sine, and we have 8 and in the denominator because of the coefficient of x. Then cos here again becomes sine, so that will be sine 4x by 4. This becomes 2. 1 by 64 still outside. X plus x by 2 plus sine 8x by 16 minus sine 4x by 2 plus c. And you can just simplify all this, multiply by 1 by 64 to get the final answer. Okay guys, the fifth sub question of question number 5 is integral of 7 cos cube x plus 8 sin cube x upon 3 sin square x cos square x. Now, because we have a plus sign in the numerator, but there is a multiplication going on in the denominator, there is no plus or minus sign in the denominator, so we can easily separate these two fractions and simplify them. So we can do 7 cos cube x by 3 sin square x cos square x plus 8 sin cube x by 3 sin square x cos square x dx. We can just write it like this as two separate integrals. Now we can go ahead and take the constants outside, and this will get cut, so we have cos x remaining. Now because it's cos x by sin square x, so cos by sin becomes cot, and we have one more sign in the bottom that becomes cosec. Because let me just show you once again. So we have cos upon sine into sine. So cos by sine, this whole thing becomes cot, and this 1 by sine x becomes cosec x. So we know the integral of this. Now let's just take the constant outside here. Again, do the same thing. Sine and sine gets cut. We have 1 sine x in the numerator. Sine by cos becomes tan, and 1 by cos becomes sec. Very simple. Now we know that the integral of this, so when we differentiate cosec x, we have minus cosec x cot x. So the integral of this would be minus 7 by 3 cosec x. So that when we differentiate this, the minus and minus gets cut. Plus 8 by 3, we know that the differentiation of sec x is sec x tan x, so this would become sec x plus c. This is the final answer. Okay guys, so the sixth question, first sub question. The question is integral of 1 upon 1 plus cos x. Now there are different ways to solve this. The most simplest way that I find is just multiplying and dividing, or multiplying the numerator and denominator by the conjugate of the denominator, like we did in 1 upon 1 plus sin x. So this would become 1 upon 1 plus cos x into 1 minus cos x upon 1 minus cos x. So the denominator becomes a plus b, a minus b, which is a square minus b square. That is 1 minus cos square x, which we know is sin square x. So we can write it directly. Now this I'm writing as 1 by sin square x, which would become cosec square x, minus cos by sin becomes cot, and 1 by sin becomes cosec. So it's minus cot x cosec x dx. And we know that the integral for cosec square x is minus cot x, and the integral for minus cot x cosec x is cosec x. So the final answer is minus cot x plus cosec x plus c. Now the second sub question of question number 6 is integral of 1 upon 1 minus cos 2x dx. So we know that 1 minus cos 2x can be written as 1 upon 2 sin square x, because this is 2x, so this becomes x. So we can take 1 by 2 outside, and we can write 1 by sin square x as cosec square x. And the integral of cosec square x is minus cot x, because the differentiation of cot x is minus cosec square x. So the final answer would be minus cot x by 2 plus c. Okay, so that's it for today guys. We finished till second sub question of question number 6. In the next video, we'll do 5 or 6 more sub questions of question number 6. So see you in the next video guys. Thank you so much for watching. Bye.